So for Hess's law, we have to make these three equations right here match this overall equation. To do that, you can flip the equations, and when you flip the equations, the delta H, if it's negative, it will become positive. If it's positive, it will become negative. So first we're going to look and see that C2H2 is in the reactant in the first equation, but in the overall equation it's in the product. So we're going to flip it. So it would be C2H6 yields C2H2 plus 2H2. So now this delta H is going to become positive. Now, the second equation, H2O is on the right side, but this H2 right here and this H2, if they're on the same side, you can add them, but as you can see, there's no H2 here. So we're going to have to flip this equation also. So it's become H2 plus 1/2 O2 yields H2O. This is now going to become a negative. Now for a third equation, C2H6 is not in the final equation. 7/2 O2 is in the reactant, but we need it in the product, so we're going to flip it, and it would become 2CO2 plus 3H2O yields C2H6 plus 7/2 O2. So that's going to become positive. Now, I'm going to box around everything that we need, but we need to make sure it has the right coefficient. So if we find 2 CO2, as you can see, it's on the right side with the right coefficient. Now, okay. Now, 3H2O is on the reactant in number 3, and in number 2 there's only 1. So we can subtract those, but that's going to make 2H2O, and we need 1. So we're going to multiply everything in 2 by 2. So then we're going to put a 2 in front of this. This will cancel out and become 1, and this will become 2. So now we have 3H2O minus 2H2O is going to make 1. But since we did that, we're going to have to change this delta H and multiply it by 2. So you're going to get negative 142.4. Alright, now we have 2 CO2 and 1 H2O. So now for C2H2, there's only 1 in this first equation. And then we need 5/2 O2. We have 7/2 O2 right here, and 1 O2 right here. And 7/2 minus 1, because they're across from each other, equals 5/2. As you can see, I did not box in 2H2 and C2H6. They're on opposite sides of the equation, so we can just cancel those. Now, as you can see, everything is correct, so all you have to do to find the final delta H is we're going to take our calculator, and we have positive 94.5 minus 71.2 because it's minus 142.4 because that's a negative right here, plus 283, and you should get 235 kilojoules. And that's your final answer.